Welcome to Get Your FRQ On. This question is from the 2005 exam. It is question 2 and it is calculator active. In the question stem, we have sand being removed from a beach at a rate of R of t cubic yards per hour. And we have sand being pumped onto the beach at a rate of S of t cubic yards per hour. The model is good for t equals 0 to 6 hours, and at time t equals 0, there are 2,500 cubic yards of sand on the beach. In part A of the question, we are asked to determine how much sand is removed for time t equals 6, between t equals 0 and 6 hours, and to provide the units. We are given a function r of t that represents the rate at which the tide is removing sand for those 6 hours. So the total amount of sand removed over that 6 hours would just be the definite integral of r of t. So we have the integral from 0 to 6 of r of t dt. We do have a given function for r of t. It's 2 plus 5 sine of 4 pi t over 25. So if we integrate that function between 0 and 6, that would be the total amount of sand removed over that 6-hour period. Now, this is a calculator active question, so please do not waste any time trying to integrate this by hand. Set this up on your graphing calculator. Use your graphing calculator to determine the value of this integral. The value of the integral is 31.816, and then the units would be cubic yards. In part B, we are asked to write a function y of t, which would be the total cubic yards on the beach at time t. In order to construct our y of t, we have to account for both S of t, representing sand being added to the beach, and R of t, representing sand being removed from the beach, and the fact that at time t equals 0, there's 2,500 cubic yards of sand already on that beach. So the total amount of sand on the beach at time t is found using the definite integral. So the total amount, y of t, would be our initial amount, 2,500, plus the integral from 0 to t of s of x minus r of x dx, which we also have a function for s of t, which we would substitute in the x here. So we have 2,500 plus the integral from 0 to t of 15x over 1 plus 3x minus the function 2 plus 5 sine 4 pi x over 25 dx. Notice the change of variable here. Because y of t is a function defined in terms of t itself, and we don't want t to be one of the bounds of integration, that wouldn't make any sense. So in a situation like this, it's very common, because t is one of our bounds, we want to know how much sand has accumulated on the beach, whether or not it's positive or negative. Given these two functions, we don't want the bound to also be the variable of integration, so we typically would just use an x inside the integral. It doesn't really matter, you could use a k or a z, just don't use t. All right, so that explains the change of variable here. We don't want to use t for both. In part C, we are asked to determine the rate at which the total sand on the beach is changing at time t equals 4. Well, the rate at which the total sand on the beach is changing must account for the sand being added and the sand being removed. Both of those functions are also rates. So y of t, which we've already defined as the integral function on the previous part, represents the amount of sand on the beach at time t. Therefore, what we're actually looking for here is just y prime of 4. All right, so y prime of 4 would just be the derivative of our y of t function. Well, our y of t function was 2,500 plus the integral from 0 to t of s of x minus r of x dx. If we differentiate that, the derivative of 2,500 is 0, and by the fundamental theorem of calculus, the derivative of the integral from 0 to t of s of x minus r of x dx is just s of x minus r of x. And since we're interested in time t equal 4, we need to determine what s of 4 minus r of 4 will be. But again, this is a calculator active question, So use your calculator to do this. You don't need to spend time doing this by hand. Y prime of 4, which is equal to S of 4 minus R of 4, is going to be negative 1.909 cubic yards per hour. In part D, we consider the interval from 0 to 6. At what time t is the amount of sand on the beach at a minimum? What is that value? And justify your conclusions. If we check the functions r of t and s of t, they're the types of functions it's easily noticeable that they're going to be continuous and differentiable on the interval from 0 to 6. So if r of t and s of t are continuous and differentiable, then y of t is also going to be continuous and differentiable on the interval from 0 to 6 as well. We're not introducing any discontinuities or any places where the function might not be differentiable. So y of t, because it's continuous and differentiable, could have a minimum value either at one of the endpoints, t equals 0 or t equals 6, or some value between 0 and 6 such that y prime of t is equal to 0. Okay, if we use our calculator, we can determine that y prime of t would equal 0 when t is equal to 5.117865. And note the added precision here. The reason for the added precision here is this is an intermediate step for this problem that we are using our calculator to determine this value. If we round this value or truncate this value, we may end up being off by a small bit, but being off by a small bit at the end can cause you not to earn a point. So we use the added precision here to make sure that our final answer is still going to be correct to 3 decimal places. Well, we can determine y of 0. That's given. Y of 0 is 2,500. That's given in the question stem. We can use the value of t that we just found to determine what the minimum value would be when y prime of t is equal to 0, or at least what the value of that function is. It's 2,492.3694. Got that from our calculator. And we can use either our calculator or do it by hand. Probably going to use a calculator here to determine y of 6, which is 2,493.2766. And if you compare these, you can see that the sand is at a minimum when t is equal to that 5.117865 answer. And the amount of sand on the beach at that time is 2,492.3694. And remember, correct to 3 decimal places, so even if you don't round these in your answer, they're going to stop reading after the 3rd spot. And if it's correct, either truncated or rounded, you will get those points.